Welcome to openmentor.net. In this session we are going to see Java control statements. I have got an integer I equal to 10. I am doing a simple condition. If I greater than 0, if is one of the basic branching control statement. It takes a decision. It makes a logical decision. This is a relational expression. This is called a relational expression. This symbol is greater than. This is called a relational operator. So if it is greater than 0, I am printing it's positive. Else I am printing it can be either 0 or negative. So this is a fundamental if condition to do some check on some entity. It may be integer or it may be float, it may be a string, but I am doing one simple comparison. Let us execute this. It says it's a positive number because 10 is positive number. Now I am giving -2. Let us see. If it is positive, it executes this. If it is negative, it is supposed to come to this portion. So if the condition is true, this portion is executed. If the condition is false, this else is executed. Now it says it is 0 or negative number. Now I want to have one more if condition. So if I want to see, okay, it is not greater than 0, I want to check whether it is 0. Now we can say else if I equal to 0. You have to use two equal to sign to see equality. Now I can say it is 0. If this also fails, that means you have to have another else. Now I am saying this is negative. So we are giving three branches over here, three path. One is this path if it is positive. If it is equal to 0, this path. If this condition and if this condition fail, then it comes over here. So this structure is called if else. Let us compile this. Now let us execute this. Now it says negative. So because I have given -2. So previously we executed this path. Now we executed this path. Now let us give this value as 0. See how it works. It says 0. So the branching, depending upon the result, positive or negative, or say true or false. If this is true, this portion is executed. If it is false, it comes over here. Again it executes this condition. If this is true, this is executed. If this condition is false, then this else is executed. So this is the basic relational conditions. Pretty much you can use double equal to for equal to, right? This is equal to. Same way, if you want to say greater than, less than, greater than or equal to, or less than or equal to, you can use. For not equal to, you have to use this exclamation mark and this one. So not equal to, you have to use this symbol. So you can use any of these operators in the if conditions. This is called a relational expression. Now let us do one more advanced stuff, which is called logical expression. That means multiple relational expressions clubbed together by logical operators. Let us see one of them. Let us take this example. I am trying to find whether a given year is leap year or not. I am taking year equal to 1940. Now in the relational expression itself, I am having an arithmetic part. Previously we have done only just a variable greater than 0, just a variable operator and then a value. Now I am saying I %4, this is modulus operator. That means the remainder. If a year is divisible by 4, and I say remainder is not equal to 0, that means the remainder is not equal to 0 means it's not divisible by 4. If it is not divisible by 4, then it comes over here. Then I'm saying, okay, if the year is divisible by 100 and not divisible by 400, then still it is not a leap year. If it is not satisfying these two conditions, I am coming over here. So what you see here, it's an improved relational expression where you have one portion is arithmetic expression. First this is evaluated, then that result is compared to this. If you see this condition, this is one separate condition. This is another separate condition. Put together, clubbed with or combined with logical AND. This is called logical AND. This means to make this whole condition to become true, this individual condition must be true and this condition must be true. Only when both are true. If one particular year is divisible by 100, it should be divisible by 400 also. If it is not a leap year. If it is divisible by 100 only and not divisible by 400, it's not a leap year. But if it is divisible by 4, not divisible by 100, then definitely it's a leap year. So let us try testing this one. 1940 is definitely a leap year because 40 is divisible by 4. Let us check this out. Let us compile this. 1940 is a definite leap year. Now I'm going to do 1941. So 1941 cannot be a leap year. You and I know that. Let us see whether my program works fine. Very good. 1941 is not a leap year. Very good. Now I'm making 2000. 2000 is a definite leap year. Let us compile and then execute it. 2000 is a definite leap year. Whereas let us take 1900. 1900 is divisible by 4. But there is another condition for leap year. If this is divisible by 100, it should be divisible by 400 also. 1900 is not divisible by 400. So this condition becomes true, but this condition becomes false. The whole thing becomes false. The control comes to this place. Let us execute this. So 1900 is not a leap year. So you can have simple conditions like this. You can have an arithmetic expression within the relational expression, or you can have two or more relational expressions combined with either logical AND or there's a logical OR. Two pipeline symbols. If you use that, that is logical OR. That means if any one condition becomes true within the whole expression, the whole condition will become true. So you can use either logical AND or logical OR depending upon your application logic. So this is the fundamental if, else, else if. So there is a way that you can prepare basic conditional relational expressions as simple expressions or arithmetic operations within the relational expression. Then you can have multiple relational expressions clubbed within a logical expression. We will stop this session here. Thank you.